Hello, 8th graders, and we are continuing with Chapter 5. Now, before we continue, I want to take a moment to discuss the properties of equality. You do not need to write these down, but I want you to pay special attention to this last one. This one is new. The rest of these are the same things as equations, except they're inequalities. Addition property, subtraction, multiplication, division. Transitive property you've done, but now transitive property would say if A is less than B and B is less than C, then A is less than C. So, we're now going to look at the comparison property. The comparison property of equality says that if you have two numbers added together that equal C, and one of those, either A or B, has to be greater than 0, then the one that's remaining has to be has to be less than C. So, let's look at this. If I had, for example, 3 plus 4 is equal to 7. If I know that one of these is equal to 0, so in this case, let's say this one is bigger than 0. Absolutely it is. Then you would know that 3 has to be less than 7. Using the same property, you could have also had said this, for example, is bigger than 0, so you could have said 4 is less than 7. So 4 is less than 7 would also be acceptable. You can also switch it around. So you could have something that says this: 9 is equal to 5 plus 4. Well, by the comparison property, we could say that if 9 is equal to 5 plus 4, then 9 would have to be greater than either 5 or 9 would have to be greater than 4, as long as the other one of these numbers is greater than 0. So whatever one we're talking about, it has to be greater than 0. So this is called the comparison property of inequalities. Now in section 5.6, we're going to talk about inequalities in two triangles. Now, I want you to look at this carnival ride. Now you're probably looking at this going, okay, what does this have to do with math? This actually, believe it or not, is what we're going to start talking about today, which is called the Hinge theorem. Think of it this way on the ride. In this ride, each of these cables that holds one of these riders is attached to the actual base or the top part of this ride. As it gets faster, this little spot where each of these chains or supports are braced acts like a hinge. And the angle measure, so for example, if I did this, the angle measure between each of these gets bigger, because this right here is your angle measure. Let me mark it in white. This right here is your angle measure. This gets bigger. This piece here and this piece here remain the same in the triangle. The only thing that changes is the angle measure, which causes the third side to either get smaller or larger, depending on what the angle is. That today is what the hinge theorem is going to state, because this acts as a hinge, which changes the angle measure. It does not change the two sides that are located on each side of this angle. So now I'm going to move this away, and let's leave it right there. And let's add the rest of this. So in this lesson, you're going to apply inequality relationships between two triangles. So the two theorems that you're going to learn about today involving inequalities within two triangles are the Hinge theorem and its converse. So here's what the Hinge theorem says. Look at the picture, don't follow along with the words. It says that if you have two sides of one triangle congruent to two sides of another, and the included angles are not congruent, that means one's bigger than the other, then the longer side is across from the longer included angle. So, if we're looking here, we have two sides that are congruent to two sides. The measure, notice we're talking about the measure here. The Hinge theorem only talks about the measure of angles and the lengths of sides, not the actual segments, not the actual angles. So we would say the measure of angle A is greater than the measure of angle D. Now that's the hypothesis, so this is going to be given. You can't just look at it and say, well, I think it is. You have to know that it is in the hypothesis. Then your conclusion by the Hinge theorem would state that the length of BC is greater than the length of EF. The converse is just the opposite of that. If you have two sides that are congruent of one triangle to two sides of another, and you know that the length of one side is greater than the other, then you know that the measure of that angle is greater than the measure of the other angle. So in this case, we know that two sets of sides are congruent. Then we know and are given that GH is greater than KL, so therefore we can say that the measure of angle J is greater than the measure of angle M because of the converse of the Hinge theorem. Alright, so let's do example number 1. Example number 1, we're going to use the Hinge theorem and its converse. So we're going to start with A. We want to compare the measure of angle PQS to the measure of angle RQS. So let's look at what we have. We know that PQ is congruent to RQ. We then know QS will be congruent to itself. Therefore, we know that we have two congruent sides of one triangle that are congruent to two sides of another triangle. So what do we then know? Well, we know that this length is greater than this length. So how do we compare the measure of angle PQS and the measure of angle RQS? We would say that the measure of angle PQS is greater than the measure of angle RQS. And the reason behind that is because of the converse of the Hinge theorem. So now we want to compare the length of KL and the length of MN. So I'm going to highlight those red just to look at them. So what do we know? We know that this would be congruent to itself, the length of LN. And we would know LM is congruent to KN because the segments are congruent because their lengths are the same. So now we look at the included angle. We had an included angle of 57 degrees and an included angle of 53 degrees. 57 is greater, therefore we know that the side across from it, its length is going to be greater. So MN would be greater than KL. So the length of MN is greater than the length of KL. Or you could say the length of KL is less than the length of MN. So now we want to find the range of values for Z. This is where we have to do some math. Well, what do we first know? We know that TV is congruent to itself. And we know that this side and this side are also congruent. So then we look at the included angles. The included angles are 6Z minus 3 and 45. Well, let's look at the sides across from it. This length is 25, this length is 24. So which angle has to be greater? 45 degrees has to be greater because, why? Well, because of the Hinge theorem, it says that the angle and the side across from it, the bigger angle inside, means it has to be greater than the other triangle. So we know that 6Z minus 3 would have to be less than 45 degrees because 45 has to be greater. So we solve this. 6Z is less than 48. And so Z would be less than 8. So Z has to be less than 8. But we have more to it than that. We also know that 6Z minus 3, since it's an angle, we know it has to be greater than 0. So remember, we have to make that greater than 0. So if you solve that, we add 3, divide by 6, that would be Z is greater than a half, or 5/10. So our range would be this. A half is less than Z, which is less than 8. So the value of Z has to be between a half and 8. Example number 2. The angle of the swings in a circular swing ride changes with the speed of the ride. The diagram shows the position of one swing at two different speeds. Which rider is farther from the base? Now you're going to look at this and go, are you kidding me? This is easy. But you have to explain it. Obviously, rider B is going to be farther from the base. But why is that? Well, let's look at what we have. We know that this chord and this chord have to be the same because they're not going to change. We know that this length has to be equal to that length. So the included angle, which is here, well, this one is a smaller angle. This one is larger. Therefore, we would say that rider B is farther away. And why is that? Because it's by the Hinge theorem. The Hinge theorem would say that if we know the angles, rider B is farther away because of the Hinge theorem. All right, our last example, example 3, is a 2-column proof. In our given, we know that KL is congruent to NL, segment NL. We want to prove that the length of KM is greater than the length of NM. Number one, I'm going to redraw these as 2 separate triangles since they overlap. So we start off with our given. Segments KL and NL are congruent. So as you can see, I've marked them congruent. And there's your hinge. Angle L here in both these triangles is the hinge. We take it and it moves and it swings and gives you this. So this side swings to give you that. So what do we know? Well, we have one set of sides that are congruent. We can also say our second set of sides, which are segment LM, is congruent to segment LM. And why is that? Because of the reflexive property. So we know that those are also congruent. So now we look at the angle between them. The angle between them is what we need to talk about. And since we're talking about the Hinge theorem, we have to use the measure. So we're going to start with the measure of the angles. Well, what do we know here? We need to know this angle here. So we could say the measure of angle KLM. But what does that equal? Well, we have to find this measure of that angle as well. But this is a part of this angle. So we're going to say the measure of angle KLM is equal to the measure of the 2 angles that make it. So the measure of angle, let's do MLN, plus the measure of angle KLN. And what do we just use? We use the addition postulate, the angle addition postulate. So the angle addition postulate says that the measure of angle KLM is equal to the measure of angle MLN and the measure of angle KLM. Now, why did we want to know that? Because we want to get down to, I'm going to mark it in, let's mark it in green. This angle here and this angle here. Well, this is a part of the angle. So we only want this angle and MLN, which is this one. So we have to get rid of this one. Well, what did I teach you at the beginning of this lesson? We talked about the comparison property of inequality. The comparison property of inequality stated that if you had one piece equal to 2 others added together, as long as this one is greater than 0, which it is, we can say the measure of angle KLM is greater than the measure of angle MLN. And the reason we can say that is because if 2 things added together to give you an angle, if you eliminate one of them, then the other one obviously has to be smaller than the big angle. So, what do we just use? We used the comparison property of inequalities. And then our last step says this. We just figured out the measure of the angles. So the measure of angle KLM is greater than the measure of angle, this angle right here, MLN, which is what we want. Those are across from the sides we're comparing. So then we can say that the length of KM is greater than the length of NM. And why is that? Because of the Hinge theorem.